Welcome, welcome. Today we're going to talk about chemical reactions, objective 1 and 2. We will do a small group on 3 and 4 next time I see you during PLT. So far you should have passed structures and property of matter. The major objectives for this playlist was to describe the structure of atoms and how they combine to form molecules. So you learned about atoms, elements, and molecules in this playlist. Objective 2 is to describe different physical and chemical properties of substances. Objective 3 was all about our states of matter, solid, liquid, and gas. And objective 4 was how temperature and pressure causes matter to change state. Today, we are going to learn about how a chemical reaction, the atoms are regrouped into different molecules with different properties. So like how a chemical change takes place and what happens. Objective 2, we're looking at how to interpret chemical equations, so balancing those equations. Objective 3, we're going to describe the law of conservation of mass and matter. And then objective 4, we're going to talk about endothermic and exothermic reactions. So for objective 1, you can feel free to take notes and pause the video, or you can follow along. These slideshows have been emailed to you in the whole presentation for today, so you have access to them there as well. So during a reaction, the biggest thing is that the bonds are being broken. So atoms are then rearranged and new bonds are formed. So substances can be broken apart or joined together, or some combination of the two during a chemical reaction. The big thing is that bonds are broken in a chemical reaction. So we are making totally new stuff. The substances entering a reaction are called our reactants. So anything to the left of this arrow are called reactants, and the resulting substances with new chemical formulas are called our products. So anything to the right of the arrow are called products. So whatever is being produced is a product, right? So the physical properties of the reactants are always going to be different than the physical properties of our products. So, for example, the reactants of H2 and O2 are both gases. When these two combined, they form H2O, which can be produced as a liquid, a solid, or a gas, water. So the parts of our chemical equation, again, anything to the left of our arrow is called reactants. Anything to the right are called products. The arrow, when you read it, you say yields. And that's what is the reactants becoming the products through that chemical reaction. So sodium and chlorine yields sodium chloride. Some other things that you might see are these like things in parentheses, right? That's just the state of matter that those chemicals are in. So solid, liquid, gas, SLG. AQ is aqueous, and that just means that it's dissolved in water. And then, again, anything to the left are reactants, anything to the right are products. And a great way to identify how many reactants or how many products you have is each different molecule is going to be separated by a addition sign. So we have 2 reactants in this one and 2 products in this one. So if it's asking you on your test which ones are the reactants and you don't know what these are called, you can always check your answers below and just make sure that the number ends up answering your question. We also have periodic tables in the back of my room on the red bin that you can also check with to see different element names. So reactants are the substance present at the beginning of a chemical reaction. So for example, we have here the burning of natural gas. So our methane and oxygen are going to be the reactants in this chemical reaction. And then carbon dioxide and water are going to be the products formed in the reaction. And reactants and products can be elements or compounds depending on what reaction is taking place. But the big thing is these bonds are being broken and rearranged and new bonds are being formed. The coefficients are the big numbers and the subscripts are the little numbers. Sometimes on your test, these subscripts look big in the middle. Just know that a subscript always is going to be found in between letters or maybe after them. A coefficient is always in the front. And what happens is, for example, you can pretend like it's something like this. So the coefficient is here, it's a big 2, and then I've got H2O, and it is multiplying that whole molecule. So 2 times 2 is 4 hydrogen atoms, and 2 times 1 is 2 oxygen atoms. Coefficients are going to be used to balance equations, but you can never change the subscripts. We can change this number, but we can't change the subscripts. Like CO and CO2 are 2 different molecules. So our chemical reactions, the definition is a process in which one or more substances, which are called reactants, change into one or more substances called products with different physical and chemical properties. And in order to identify a chemical reaction, here are some really good indicators. Again, they're not always true, but these are some good things to look for. So a change in color, a formation of a precipitate, and remember, a precipitate is when 2 liquids mix together and make a solid. A release of gas, we did a definition for bubbles. An energy change, so heat, light, or sound, or an odor change. So some really good acronym to help you remember these is the acronym FARTS. So does it fizz? Does the reaction produce bubbles? Is there a new aroma? Did it produce a smell? Replacement, did the reaction replace any of the original substances? Temperature, did it produce a temperature change? Was it hotter or colder? Or a new substance, did the reaction produce a new substance? Typically a chemical change is really hard to reverse. I know it says can't here, but it sometimes can. It's just very difficult compared to a physical change. So some practice. The substance entering reaction are called the reactants. The resulting substances with new chemical formulas are called products. The properties of reactants are always different than the properties of the products. And during a chemical reaction, bonds between atoms in the reactions are broken and new bonds are formed in the products. We also want to talk about some chemical and physical changes. So chemical changes are not easily reversed. New products are going to be formed. Reactants are used up. Often heat, light, sound, or fizzing occurs. Electricity could be produced. A precipitate may form. Remember, 2 liquids make a solid, it's a precipitate. So a great example of a chemical change would be wood burning. A physical change is easily reversible. There are no new products. Often it's just a change in state of matter. So a great example is ice melting. So some practice with this. If I fold paper a bunch of times, that is a physical change, right? Still paper, doesn't matter. Fireworks exploding, on the other hand, is a chemical change, something totally different. So a metal bike is rusting if left outside. That is a chemical change, rusting, oxidation, right? Chemical change. Some other ones that we can talk about. Mixing sugar with water is actually a physical change. We can actually reverse that. Baking cookies, right? The dough, and then now I have an actual cookie. Really hard to reverse that process. That is a chemical change. A towel drying. The liquid's wet, right? Over time, it's evaporating off. It's turning to a gas, so that is actually a state of matter changing, so it's a physical change. And then chewing a cookie is down here. It says be very careful. The chewing process, it's actually just breaking the cookie apart, would be a physical change, but if you actually swallow it and digest it, that is a chemical change happening. There is a Kahoot on this. You probably will not be able to play it today in class, but we can do that game when you come to our small group on Tuesday. Objective 2 is all about balancing equations. So there is a brain pop video here that I want you to click on and watch. It's got really good information, talks about the periodic table, but we're going to talk about this part. So pause right now, watch this video, and then come back to me so that you can finish up with this. So we are going to talk about this chemical equation and if it's balanced or not. So I've highlighted these in different colors, these different elements, right? And really the idea is we want this side to have the same number of atoms as this side. So Fe is iron, O is oxygen, and C is carbon. They are the same colors on this side, whatever element they are. So these subscripts go with Fe and oxygen, right? But I'm going to multiply with this 2 coefficient. So it is saying I have 2 of these molecules. So 2 times 2 is 4 iron atoms, and 2 times 3 is 6 oxygen atoms. And then I only have 1 carbon here. On this side of the arrow, I have 1 iron atom. And over here I have 3 times 1 is 3 carbon, and 3 times 2 is 6 oxygen. So my oxygens are working out, but my iron and my carbons are not. So what I would need to do for this is I have 4 on this side and only 1 on this side. I need to add a coefficient to this side. 1 times what would give me 4? Obviously that would be 4. So I would add a 4 coefficient in front of this. The 4 and 4 would work out, 6 and 6 works out, but I still only have 1 carbon on this side and 3 carbon atoms on this side. So what times 1 would give me 3? So I would add a 3 coefficient in front of carbon, and then that would make this whole equation balanced. Some symbols that you can find in chemical equations. The arrow means yields. The double arrows mean that it's reversible, can go either way. S would be a solid. The arrow down is the same thing as a solid, but it's actually a precipitate. So again, those 2 liquids are combining to form a solid. L stands for liquid. AQ stands for aqueous, just means it's dissolved in water. G stands for gas.